You're going? Mm-hmm. Technical video on potentiometers and rheostats. Those of you who don't know what a rheostat is, this is an old style rheostat. It's a light dimmer from many, many, many years ago. It's a variable resistor. There's a wiper right there, wiping across these wires. You can put voltage in here and get voltage out there, and as you turn this, it varies the voltage. These little things in here are miniaturized these, except this has a stop where you can't go more than the end. Okay. These you can keep screwing. Now, I was just given one of these we've been using for years that is non-calibratable. And after 15 years dealing with non-calibratable units, going back to the supplier, I said enough is enough. How do we make it so we can get them back in range? The reason they become non-calibratable is the rheostat gets turned past its 0 point and it keeps going. The wiper comes off the metal. So if you have a potentiometer, pHma, and it won't calibrate, you take a screwdriver, you put it in the first screw, and you turn it counterclockwise 25 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Can I ask this call?
Take the other one.
Listen, give me 1 second. Okay. Listen.
Same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. What I just did is I just turned it, turned them all, both of them to 0, off the end. Now, if you take the span and you turn it clockwise 4 times, 1, 2, 3, 4. You take the 0, turn it clockwise 5 times. 1, 2, 3, 4, 5. You're now back in range. Prove it, right? Bob, prove it. Okay. This has been calibrated. I'll switch the power over here.
So you're trying to steal a secret out there.
Huh? Okay, I'm connecting up my DC power. This is a milliamp current loop transmitter. I have a pH probe here, which is currently sitting in a buffer solution of 10. Unplug that. Plug it in. Put back on the ground pin. We take our milliammeter, which I'll just turn on. I can 0 it. Attach this to the blue wire, which is the current flow. Step 1 says to put the probe in a buffer solution of 7. There, she's in 7. The negative is on there because I could have this backwards. I can turn it around and it becomes positive. Isn't that beautiful? Okay, We're on a pH of 7 at 10.92 milliamps. We want to be at 12 milliamps. We do a zero adjust. This is a logarithmic analog circuit in here. There's a time delay. That means there's capacitors and inductors at play in here. So it is a slow response circuit, unlike a light switch which turns lights on and off. So you can overshoot, you can undershoot. So I'm getting close to 12. And then I'm going to go to the pH of 10, which should go to 15.4. And I'm going to come back to the 12, and you go back and forth a couple times until it reads 12 and 15.4. There, I just broke over 12. Back it off a little bit. Close enough for the first pass. Dry off to the end of the probe. Put it in my other solution. This is going to go up. It's going to go up above 15. I want 15.4 in, remember that. And this will be a span adjustment. .8 is where it went to. I'm close. Turner. It's very sensitive. The span's a very sensitive adjustment. It's a little bit. It's a lot of reading change. There, 15.45. Dry it off. Back on 12. .2, 12.04, it's going to go under just a little bit. I'll bring the zero up. And gotta give it time to settle. I'm doing this a little bit more rapid than is needed. If I had better glasses on, I could see the, there we go. I'm 11.7, very close. That's on my first pass. .93. .8. 11.99. 12. It may overshoot a little bit. We're within 1/100th of a milliamp. That's a microamp, just for those of you who are mathematically inclined. Back to 15.5. 15.6. We're looking 15.4. So I can have 15.4. Oh, sensitive turn. One last check in the 12. Almost there. 11.95. Real close. A couple more cycles of this calibration and she's back in operation. So that's the end of how to bring these back in. Turn these counterclockwise 25 times. It turns the rheostat from wherever it is all the way to one end. So counterclockwise 25 times. You turn the span clockwise 4 times. Turn the 0 clockwise 5 times. It puts you in the approximate range as you now see is starting to calibrate. It takes a little more back and forth and a little more patience in letting it sit and settle before you make these adjustments. But this was due to go back to the supplier to have them do what we now know how to do here. 25 times one direction, you've zeroed it, bring it back on, done.